Before stealth, before artificial intelligence, before unmanned platforms, speed decided who survived and who never returned. These aircraft didn't break records, they redefined the physics of air combat. In the early Cold War, speed wasn't a luxury, it was survival doctrine. Soviet nuclear bombers could reach American cities in hours. NATO reconnaissance aircraft had to penetrate denied airspace and escape before interception. Fighter pilots understood a simple truth. If you couldn't outrun the threat, you wouldn't outlive it. The United States and Soviet Union began developing aircraft that operated at the edge of what metal, fuel, and human physiology could withstand. These weren't just faster planes. They were engineering answers to strategic questions that could determine the outcome of global conflict. But pushing past Mach 2 introduced problems no previous generation of aircraft had faced. At Mach 3, the leading edges of an aircraft reach temperatures exceeding 600 degrees Fahrenheit. Aluminum melts. Conventional hydraulics fail. Even the fuel becomes a heat management system. The SR-71 was built from titanium, one of the few metals that could survive sustained kinetic heating. But titanium expands dramatically under thermal stress. Lockheed engineers intentionally designed the Blackbird with loose-fitting panels. On the ground, it leaked fuel. In flight, at operational temperature, the airframe expanded and sealed itself. Pilots wore full pressure suits, not for altitude alone, but because at 85,000 feet and Mach 3+, a cockpit breach meant death in seconds. These weren't aircraft you simply flew faster. They were systems designed around the brutal realities of compressible flow, thermal expansion, and the limits of human endurance. The Lockheed SR-71 Blackbird remains the fastest air-breathing manned aircraft ever built. Operational speed, Mach 3.2, over 2,200 miles per hour. Operational ceiling, 85,000 feet. Its missions were simple: penetrate hostile airspace, photograph strategic targets, and outrun anything sent to stop it. No SR-71 was ever shot down. Pilots didn't evade missiles, they outran them. When surface-to-air threats locked on, the standard response was to accelerate. By the time the missile reached intercept altitude, the Blackbird was already gone. It flew reconnaissance missions over North Vietnam, the Middle East, and Soviet territory. Its cameras could photograph a newspaper headline from 16 miles up. The SR-71 was retired in 1998, not because it was obsolete, but because satellites and stealth made speed less critical than invisibility. When Western intelligence first identified the MiG-25 in the mid-1960s, they assumed it was a revolutionary air superiority fighter. It wasn't. The Foxbat was designed with one mission: intercept NATO reconnaissance aircraft and strategic bombers at extreme altitude and speed. Maximum speed, Mach 2.83. Operational ceiling, over 80,000 feet. Unlike the Blackbird, the MiG-25 wasn't built from exotic materials. It used nickel steel, because the Soviets prioritized mass production over refinement. In 1976, Soviet pilot Viktor Belenko defected to Japan in a MiG-25. When U.S. engineers examined the aircraft, they were stunned, not by sophistication but by brute force effectiveness. The engines could push the aircraft past Mach 3, but only at the cost of total destruction. Soviet doctrine accepted this. If the pilot intercepted the target, the mission succeeded, even if the aircraft didn't survive. The MiG-25 proved that extreme speed didn't require perfection, it required commitment. The MiG-31 Foxhound was the Soviet answer to a strategic problem. How do you defend the longest border on Earth from cruise missiles and stealth bombers? Unlike its predecessor, the MiG-31 wasn't just fast. It was a networked weapons platform. Maximum speed, Mach 2.83. Combat radius, 450 miles. But its real capability was the Zaslan radar, the first phased array system ever deployed on a fighter. 4 MiG-31s operating in a defensive line could monitor a front over 500 miles wide, They could engage multiple targets simultaneously at ranges exceeding 100 miles. While the West focused on agility and stealth, Russia doubled down on speed and reach. The MiG-31 remains operational today, still one of the fastest combat aircraft in service, still defending Russian airspace from threats most fighters can't even detect. The North American XB-70 Valkyrie was supposed to be the future of strategic bombing, a Mach 3 bomber capable of flying above Soviet air defenses and delivering nuclear weapons without ever slowing down. It was enormous. 6 engines, a cruising speed of Mach 3, wingtips that folded downward in supersonic flight to ride its own shockwave, compression lift, a technique never used before or since. Only 2 were ever built. The program was canceled before production began, not because the Valkyrie failed, but because intercontinental ballistic missiles made high-speed bombers obsolete. In 1966, one of the 2 Valkyries was destroyed in a mid-air collision during a photo flight. Pilot Al White survived. Co-pilot Carl Cross did not. The surviving XB-70 is now on display at the National Museum of the United States Air Force, a monument to the era when speed was still believed to be the ultimate defense. Modern 5th-generation fighters rarely exceed Mach 1.6 in operational missions. The F-35's top speed is Mach 1.6, the Su-57, Mach 2. Even the F-22 Raptor, designed for air superiority, seldom pushes past Mach 2 in combat. Why? Because air combat doctrine changed. Beyond visual range missiles engage targets 60 miles away, long before speed becomes relevant. Stealth allows fighters to approach undetected. Network-centric warfare means the aircraft itself is just one node in a kill chain. In modern air combat, seeing first and shooting first matters far more than flying fastest. Speed remains tactically useful. Supercruise capability allows sustained supersonic flight without afterburners, preserving fuel and reducing thermal signature. But no Air Force is designing Mach 3 interceptors anymore. The era of manned Mach 3 flight may be over, not because the technology disappeared, but because the mission changed. Satellites can photograph any point on Earth without crossing hostile airspace. Stealth platforms penetrate air defenses by avoiding detection, not outrunning interception. Hypersonic missiles travel faster than any piloted aircraft, but they're expendable, unmanned, and don't need life support. Building a Mach 3 reconnaissance aircraft today would cost billions. Training pilots for high-altitude pressure suit operations is expensive and dangerous. Titanium fabrication at the scale required for sustained hypersonic flight remains prohibitively complex. The SR-71, MiG-25, and their contemporaries existed because Cold War doctrine demanded platforms that could survive where stealth and satellites didn't yet exist. That world is gone, and with it, the need for aircraft that could outrun the sky itself. These aircraft didn't just break records. They defined an era when survival depended on speed, when pilots trusted titanium and afterburners more than stealth and electronics. They pushed the limits of physics, engineering, and human endurance, not for glory, but because the mission demanded it. And history will never forget what they achieved. If you made it this far, drop the word fastest in the comments. Hit that subscribe button, turn on notifications, and smash the like button if you want to see more military aviation history like this.